Okay, so I've just been working on some Ambisonic tools for Max for Live, and I've got some first order Ambisonic and second order Ambisonic encoders, decoders, and hosts. And for me, it's just the de facto way of doing this is by using Envelope for Live, at least in Ableton Live. And even though Envelope for Live is great, it does have a bit of overhead when it comes to if you wanted to have panning across lots and lots of different sources. And so, yeah, I wanted to make something that's a bit more lightweight potentially. And also, I don't always need third order Ambisonics. So maybe I want to just get a sense of directionality with my signal. Maybe I'm not decoding it to that many speakers, and so we don't need to carry all 16 audio signals that is inherent to a third order Ambisonics signal. And so here you can kind of see how beautiful and simple the maths is behind first order Ambisonics. Basically, we're taking a mono or stereo audio signal and then we're encoding it at an audio rate using a multi-dimensional vector, at least that's the way that I like to think about it, into spherical harmonics. And over here I've got a GitHub repo that just basically has either first order with 4 signals or second order with 9 signals. And I've got some encoders, decoders, and plugin hosts. The role of the plugin host plugins is just making it easier to deal with multi-channel signals inside of Ableton and to be able to do things like take the 9 signals from a second order Ambisonics track and process them using a binaural plugin and then just giving you a stereo output. So let's have a look at some of these. I'll go through some examples. So here I've got a basic live session and just this sound on loop. And so what I want to do is first set up my decoders, which is basically where we choose a playback position from within a 360 spherical field. And then we can set up some encoders, which are basically a way of panning with both angle and elevation. And so I'll show you the first order versions of these. So here's the decoder. And so the decoder gives you a set of 8 possible outputs. You don't have to use all 8 if you don't want to. I'm just going to use the first 2. But the idea here would be you might have 4 speakers, you might have 8 speakers, and you can choose what's the azimuth, so what's the horizontal angle, and what's the elevation, so what's the vertical angle. And you can kind of think about these outputs as representing listening points within that sphere or virtual microphones within that sphere. So let's just do something basic. We'll go like minus 90 degrees, so that'll be like a left-hand signal. 0 degrees would be center. Elevation would be 0 degrees because I just want it to be horizontally flat. And then for the second output, we'll go 90 degrees to the right. So elevation will be 0 degrees as well. Output here, we could go external output, but I'll keep it on no outputs and just mirror this directly to the left and right output of this decoder. So basically set up a decoder there, and it's just first order Ambisonics, and you can see here the Ambisonic signal coming in. And then over here, we've got our track that we want to encode into this Ambisonics bus. And I'll use the stereo encoder just because it has a few extra options for us. First thing we need to do is just tell the stereo encoder to send its signal to our main output. And here, the order is just going to be 3 and 4, and then 5 and 6. And so now we've got azimuth and elevation for the left input, and then angle of azimuth and elevation for the right input. So we could have these set to, we set them both to minus 90 degrees. What we should hear is a lot of signal on the left-hand channel of our main output and not much on the right. Like that. Now as we pan around, we can hear it in both left and right. Now what we can do here is we can basically link these two together and then set a difference from left to right. And so this way we could just have like a kind of have a bit of control over the width of this apparent signal when we hear it from the decoder. But note that this is not doing iterative projection into the sphere. It's just the left and the right signal. So if we have these two very far apart, then we will probably hear them as two distinct sources as opposed to combined together if we're, especially in higher order ambisonics. Like that. We can also mirror these two, so we could start off with like, especially if we had 4 speakers set up or 8 speakers set up, we could start at minus 180 degrees, which is from the rear, and then we could bring that around and then snap it to the front like this. Or we can just leave them unlinked. We've got similar kind of options for elevation. Elevation is only going to go from minus 90 degrees to plus 90 degrees because the front and the back elevation are identical. And note that because we're elevating into a sphere, the higher up we go, we're going to lose directionality of the azimuth angle. So the more centered that becomes. And so if elevation is at exactly 90 degrees, we're going to lose all horizontal information basically. And then down here, we've also got a distance parameter. So this is kind of faking distance because Ambisonics does not encode distance, it only encodes angles. And so, yeah, distance is just kind of getting faked just by a change in gain of the signal. Let's just try that out quickly. And it's a little bit arbitrary, 0%, 100%. Like that. And all it's doing there is changing the gain. And in fact, all of these are doing are changing gains in various ways based on sort of taking the sine and the cosine of the angles that we're trying to project into. And so going back to the decoder, you can imagine having like a ring of 8 speakers by setting, let's say all of the azimuths at 45 degrees from each other. You could imagine a cube of speakers where we've got height information as well. I'm really keen on trying out some other sort of non-symmetrical setups as well, where we can project into. So things like a pyramid shape with a bit of elevation, or sort of something where we've only got speakers towards the front, but we've got some elevation happening as well. And so the thing I like about decoding in this way, where we can be really accurate about both our azimuth and elevation decoding points, is that we can just have more control over and trying out unusual speaker type setups. Of course, none of these speakers are going to be, especially with first order ambisonics, we're not going to get that good spatial resolution. And so that's where kind of the second order ambisonics come in. So to do first order, we need 4 audio signals that we're encoding as. And then if we get rid of both of these, so you've got all these second order ones. And so you can see the second order decoder also has 8 output possibilities, but it takes 9 channels as an input. So as a result, the second order encoder will also output to 9 channel, basically a 9 channel bus, like that. So let's take this as an example, and instead of decoding to left and right discrete points, let's try a plugin host. So here I've got a 9.2, so meaning 9 inputs, 2 outputs, Ambisonics host that takes a second order signal. And let's just find a plugin. And to be honest, I'm never that never that convinced by binaural encoding stuff, binaural decoding stuff. I've never heard something that gives me a really good idea about height or about the sound coming from behind me. I don't mind the IEM stuff. It's free and it does an okay job, but I feel like all of the different algorithms that are used to decode from an ambisonic signal into a binaural signal, all of them sound slightly different. They've all got a little bit of weird phasing stuff happening and just a bit of weird level stuff. So I don't find any of them that convincing. If you've heard of one that you find really convincing, let me know, because I'd love to try it out. So here we can just go load and select the IEM binaural decoder. We can open that up. And you can see, because this plugin instance inside of Max for Live has 9 inputs, it's automatically detected the second order Ambisonics. So what we should be able to do is just route our outputs to main, and then in order we can go main 3, 4, 5, 6. All the way up to 11, 12. And so if I were to do multiple tracks, I could just copy this onto another track once I've done that setup, because it'll just have all the outputs already set up for me. And there we can see the signals coming in. Let's give it a bit of elevation as well. And you can see signal across all 9 inputs of the second order Ambisonics. Like that. Anyway, just thought I'd share. Going forward, I'm going to try out a few different configurations for speakers, so I'm looking forward to that. And I'm going to be running all of that just through an RME UC interface.